So if I would put a light on this.
Yes.
Oh. See?
What we are doing in this simulation, we are kind of simulating the shaking of the headlamps.
That's the favorite lab where we are testing, let's say, mechanical robustness of our products. Especially for the track, it's really high load. It's, let's say, 3 times higher than for the past cars.
Is that the maximum number nowadays, or?
It's not a maximum number. I have here one LED, but split it on the 30,000 pixels.
30,000?
And after the plasma, it glued all the way around the housing. Plasma.
Hey everyone, welcome to another SCS On The Road episode, and today we are going to bring some light to topics that we wanted to share and discover with you and learn more with you for a long time. We are here in the city of Mohelnice in Czech Republic actually, and one of the biggest, most popular, most famous brands when it comes to lights and headlamps, and not only for personal cars but also to trucks. And we've been invited here to come and see how they do their magic, how they are testing their lights, how they are developing it, designing it. We hope you will enjoy this episode. We are gonna stay here for 2 days and we're gonna do a lot of recording for you, so let's go. Hey everyone, we are really excited to learn more about everything what's on the table already, I guess.
So here we are in FORVIA HELLA company. FORVIA HELLA as a company was established in the year 2022. And HELLA itself, it's a very old company. We were established in Germany in 1899. Here we are sitting in Mohelnice. So this is HELLA location. It's a production and development location together. Regarding development, we are one of the biggest development center in HELLA worldwide. We have in business group lighting 3 major products. One product is headlamps. The other product is RCL, which is a rear combination lamps, and the third product is modules, so the lightning engine basically inside of the headlamps.
Okay, I can see those two are kind of familiar to me. Maybe our fans in the comment section can later try to guess from which vehicle those 2 headlamps are from. Take a guess.
We are around 3,000 people together with production. Development itself, it's also important to say we have 2 locations. One is here in Mohelnice and the other one is in Ostrava. Altogether in development we are like 600 people.
Wow.
Just developers, yeah? So it's really, we are developing the products. Yeah? All the products you can see on the table here are were developed here. Everything starts with quotation. We call it RFQ, request for quotation. So the customers are asking basically us, hey guys, we would need such a product. Are you able to do it for us? And there everything starts. Yeah? So they give us some first, let's say, ideas, styling data, how the product should look like, you know, to fit it into the car and so on, like some ideas about the styling and so on. And then we are basically starting to prepare the data. And obviously it's not just about the data, it's also about the product itself, how we will produce it, who will be the suppliers, how much will that cost, of course. So all these stuff is discussed during the acquisition phase.
So you must be well aware of how the next headlamps for next truck will look like many years ahead, right?
Usually it's around 3 to 4 years just development. And so basically today we already know how all of these products which we have on the table, which are currently in the serial production. So we know how the next generation will look like in 4 or 5 years on the road. Yeah.
Can you tell some biggest differences from like what was the headlamp back then and what it's today? I believe back then it was just a candle with a mirror, I guess, on a horse carriage, and now it's like laser technology and everything, right?
Absolutely, you are absolutely right. So you cannot even compare it. Like it's not like even the same product, you know, it's like completely different sport, yeah, let's put it like that. Nowadays the technology is like really, the technology developed very fast and a lot. And I would say a high-end technology is this product here, which is laser light. So basically laser is the most fancy thing you can have in the headlamp right now. And so you can also see it on this product here, which you will guess later on in the comments under the video. One version is the bulb version, halogen bulb. The other one is LED. Yeah, so you can also see the difference.
But it's the same vehicle.
It's the same vehicle. Yeah, exactly. This is the same vehicle and two different versions.
Can you tell us more how you, or what programs or what tools you guys are using when designing a headlamp?
Basically, in the design phase of the product, we are using this software you can see on the screen. It's CATIA, and everything is designed by designers in this software in CATIA.
I see it's pretty complex. You can see every screw, every millimeter of everything.
Absolutely, and this is also one big difference between the lamps maybe 15 years ago and now. So 15 years ago, the lamp was containing roughly like 15-20 parts. Nowadays, we are talking about 200-250 parts. Yeah.
You prepared for us few very interesting places to visit in your plant today. Can you tell us more what's ahead of us for today?
We will definitely walk in the design department to see the designers and how they work, you know, their daily work. Later, we will go to the simulation department as well. We have quite a big simulation department here. All types of simulations you can think about we are doing here internally. Later in the day we will go into the laboratories as well. Yeah, we have really big laboratories here, so all the products must be tested obviously before we can release them and start the serial production. Yeah.
So before we will go and see all the exciting rooms and tests and laboratories here, we still have a table full of exciting stuff and units, but I don't know about any of them. So could you please tell us more how basically the headlamp works, like from where the light comes from the tiny spark all the way to the big cone of light that is projected on the road?
Okay, so I will guide you through the, let's say, how lights is works, yeah, in the headlights. So on the beginning we must have the light source itself. Yeah.
Yes.
So historically we know the halogen bulbs, but today we are sitting here mainly to discuss and talk about the LEDs systems. Yeah. Okay. So regarding the LEDs light sources, this is a nice example where we can see the several LEDs. LEDs are
so these are
those small yellow dots on the.
That's the source of light.
Yes,
these dots?
exactly. This is the source for the light distribution. In this case, we can see some PCBA for the matrix system.
LED sources are those squares, but how you guys are making, like, from this to make it such a big cone on a road? You put some like, I don't know, like lenses there, or?
Definitely. You need the complete optical system to spread the light on the road. We are using the collimination optics. One example you can see here. We are calling the primary optic. And then for light distribution of the spread light, we are using the lenses. In the newest system, we are projector, which composed several such lenses.
So this module, how to say it, is basically, I can see that part being here.
But in this specific case, you can see much more, let's say, light sources than you can see in here. And those LEDs light sources can be applied on one module up to 25,000.
25,000,
yes.
Those small?
Yes.
Oh my God.
What is missing here is, of course, the fan. Yeah, because the fan is also important because the power consumption or thermal dissipation in this case is really huge.
Can you tell more also about the laser, which is the newest technology, I believe? nowadays, or maybe
Yes.
you guys are already
Yes.
working on something even on top of that, but
Yes.
the laser technology, how does that work? Is it similar?
It's very similar like LEDs. The laser system you can see in this headlamp. Yeah, so the laser light source itself is here in these small boxes. Yeah, then you have optical fiber.
So you are distributing the light through the cable, through the silver cable?
Yes, yes. The yellow dots you can see here is a phosphor layer for transferring the blue one color to the white one.
So I was wrong the whole life. I thought it's the source is white, but it's not. It's blue. Actually.
It's due to the efficiency, of course.
Also, something that we all love on our personal cars or even on trucks are those, those design stripes for the daytime running lights. Can you tell us more about how those work?
Regarding the light source, it's very similar as we have in the module. It means you need the light source itself, yeah, and then you need to distribute the light through some components out. Yeah, but as you can see, this is the styling feature of the customer. Customer would like that the styling of this component should look like this. Yeah, so this is their requirement.
And this is just a design. This
is just a design, but also is an optical component. We need to somehow put out the lights from the LEDs to this final optical component, and for this we are using the light guides.
So this is just a thing that guides the light.
Exactly.
Okay, so if I would put a light on this,
Yes.
Can we try that?
Yes, you can try.
With my phone, maybe?
Put in the incoupling light.
Oh. See? And can you put that design part in front of that? Somehow? Can you try?
Yes, I can. We can, but it's not so easy because it's a very sensitive system, calculated in the tens.
But I believe our fans can get the
Hopefully
point.
it's
How does
visible.
it actually works?
Hopefully, it's visible.
That's great, right? Well, can you maybe, I know it's probably something you cannot share with us, but can you tell what the future holds? Like nowadays, the most fancy stuff is the laser lights, right? But is there anything even better coming?
Currently, the highest technology what are we using for the let's say newest car is HUD systems. It means this matrix, but in this case you have maybe 14 chips. We have matrix systems which is contain 25,000 chips. Yeah, the resolution is much higher. You are able to also put on the road example snowflakes. Of course, it's not easy from a legislative point of view.
Okay.
Yeah, so this is very sensitive topic, but this is the future because you are asking for the future.
Yes,
Yeah? So
of course.
now we are able to produce such a use cases.
But it's still in development, basically.
Exactly, it's still in the development.
Well, thank you so much for all the information, for basically explaining me and our fans how the lights works.
You're welcome.
Thank you so much. So we have moved into another part of this production plant. This is, as you guys call it, design center.
Exactly.
I mean, the name kind of says it all, but can you tell us more what your colleagues and you guys are doing here?
Yeah, the word is self-explaining. So most of our designers are sitting in this building. Yeah, we have 4 floors of designers here in this building, and basically, as you can see here behind me, the guys are working on the 3D data mostly. So we are building the data based on the one side customer requirements. Obviously, feasibility is very important. So we need to define how the parts will be produced because it's not so easy. Sometimes we have some styling from customer, but not always this styling is feasible. So we need to find out the way how to do it feasible. So.
And how long does it usually take to design a headlamp, a new headlamp, for example?
I would say in general it's several years, yeah.
Okay.
But depends on the phase of the project. So we are not designing like all the time in one row, but I would say usually 1 year.
So the customer gives you just a sketch how they would like to see the headlights to be looking, and
exactly they give us the basically styling, the styling surfaces. We call it a surface. So this is how it should look like from outside. What is their idea about the continuity of some, let's say, wave surfaces between the car and the lamp, and sometimes you also get some data which are inside already prepared from customer, but the whole feasibility is up to us. Because as you can see here on the screen, it's really so many parts. We saw it also before, very complex, and we need to also define the assembly process, how we will assemble it. So it's not just feasibility of each component, but also how we will assemble it together on the assembly line later on.
So on the way to the laboratories and to our next stations, we just quickly stopped here because you wanted to say another very important part of your work is this segment. Can you tell us what magic you guys are doing here?
Exactly. Yeah. When we are designing headlamps, it's almost all about light. So light performance is very important, and what you can see behind me. So these are the optical simulations.
What does it mean, like optical simulations?
Basically, on the previous step, what we saw, the designers are designing the parts, the reflectors, modules, and so on. And in the optical simulations, we are checking if the light performance will be as expected.
Oh, so they're working with their designs.
Absolutely.
And here they do some simulations,
yes, exactly.
to test if it's gonna work, basically.
Yeah, exactly. So we are sending the design data to them, and they are simulating. And as you can see on the color maps, the colors are representing if it's like okay, not okay, things like that. So everything is validated, position of LED to the light guides, for example, and so on. So everything is checked.
Okay.
And
if you here give the stamp that everything is fine, then the next step is to create a prototype? Or?
Exactly. And then we are creating prototypes. On the prototypes, we are tuning things maybe because it's still the simulation, just the simulation, so it's not the reality. So in reality, you have some small deviations, for example. So then we are tuning on the prototypes, yes. Okay. And once that is done, we just send the data to the tool shop, and we have, after several weeks, months, we have the first of two parts.
Perfect. So we have moved into another still simulation center, or how to say it, and you guys prepared some very cool stuff to show to us. Can you tell us more about what we're gonna see and on this monitor in a few seconds?
Yes, absolutely. So here we are in the simulation department. We have many guys who are working in the simulations here. We have many types of simulations which we are performing during the development, especially development phase of the product. Maybe we could start from the very beginning. Okay. So what we simulate first for every single component, it's this, we call it mold flow. Yeah? The software is called mold flow, and basically it's injecting of the plastic material into the mold.
Why do you simulate such things too?
There are several reasons. One reason is feasibility. So we must be 100% sure that we are able to produce this part in the quality, in the expected quality. Second aspect is decorative aspect, for sure, because with this we can see, for example, these so-called well lines. This is basically where the two streams of the melted plastic are meeting each other, and there we have some like decorative defects, for example. So with playing with parameters of this injection process, we can move these weld lines where we need to have them. And as I said in the beginning, we need to do it for every single component. So every single component we do this. So it can be hundreds components, for example, for the lamps. If the part is produced here internally in our production, in Hella production, so then we are using the parameters from the simulation also for the production to set up the injection process. The temperatures, the pressures, and other parameters which are coming from the simulation. So basically our guys from the simulation department or from development are helping the guys in the production to set up the process.
Makes sense, yeah.
This one is, I would say, maybe the most critical from the mechanical point of view. So it's the FEA simulation. What we are doing in this simulation, we are kind of simulating the shaking of the headlamps of the lamps of the products based on some defined, let's say, driving mode. So, and we need to make sure, sometimes we call it also like lifetime test. We need to make sure that the lamp will survive this shaking. Yes, we are checking these resonant frequencies. That's one thing, then based on these results, we are optimizing the design of the parts again. So adding some ribs, for example, stiffening the parts, or maybe making them a little bit softer. Depends on what is needed. And maybe what is interesting here, you see the green reflector. So how it is moving. So with this kind of simulations, we are also checking so-called flattering. So it means how much the cutoff line, basically the line of the light you can see on the road is moving. Yeah. So
that's true, because the shaking also means the shaking of the light.
Exactly.
If it would be shaping too much, it might be.
Yeah, it could be glaring, or there could be a glare of the opposite driver. And again, there are limits from legislation coming and from customers and so on, how much this can be. So all this must be checked. Important to say, here you can see it in the simulations. Obviously later on, we are checking it also on the real part. So when we will go to the laboratories later on, you can see there the same thing what we are doing here in the simulation. It's very precise, it's almost one-to-one matching, because what we are doing the so-called closed loop. So once we have the real parts and the real tests are done, we are taking the simulation results and comparing with the results, with the real test results. And if there is some deviation, we are adjusting the methodology for our simulations.
And I can see that this lamp is from a truck. Maybe again our fans can guess which brand it is and model. But would you say that the truck headlamps needs to be designed more to survive more shaking than personal cars?
Absolutely. I would say from the design point of view, designing the headlamp for a truck is completely different business. So the requirements are much more strict. So design must be stiffer because of the, let's say, using conditions of the trucks.
I can't wait to see it in the test room.
Yeah, let's go there.
So we are here in our first stop at one of many laboratories here, and I'm already impressed by the room itself. But can you describe, first of all, of course, can you introduce yourself to our fans as well, and then can you tell us what you guys are doing in this particular laboratory room?
Yeah, of course. Hello, my name is Martin Kutáč. I am head of the Photometry laboratory and the homologation department. And here in this room, we are making the photometry measurement. We are calling it dark room here because all walls are dark, are black, except of some measuring wall or viewing wall. And here we are measure some photometric characteristic of the headlamp.
What does it mean?
Does it mean amount of light, I mean light flux in lumens, intensity of light in candelas, illumination, and color, of course, because there is a dependent which function has which color, like direction indicator, yellow, low beam, white, and so on.
So you have this a little bit weird-looking machine, but
the machine
what is it?
Is called goniophotometer.
Okay.
Gonio because of some movement which we can make in X, Y, and Z direction. We are placing testing object here, and we are rotating in which angle we would like to test. And photometer because in the distance of 25 meters we have a photodetector where we measure.
So basically, you are able to position the light from the headlamp coming multiple directions.
Yes,
and you are measuring how far it can.
I can ask colleague to rotate, for example, this.
Okay, maybe we can see it.
Yeah. Yeah, the movement is a little bit faster.
So it does on its own. So it somehow can detect that I'm in.
And below we have some laser safety zone. With laser we are scanning this area, not to. When dark is absolutely to step in and
to get hit.
Crash with the goniometer.
Okay, that's clever.
Okay, thank you.
And I guess on this machine you can turn high beams, low beams, turning everything basically.
Yeah, currently we see signal functions from position lamp and direction indicator. Which we measure in a 3-meter distance.
So that's the wall behind?
Yeah,
okay.
On the wall behind. And the main function we call low beam, high beam, fog lamp, and so on. We are measuring for this 25-meter distance. This is headlamp from
a truck manufacturer. Again.
We are speaking about a full LED headlamp, full LED for all functions, signal, main beam, and low beam and high beam is created by the reflectors. We call it free-form reflectors because there are some reflectors which are shaping really the low beam, the light distribution, the bright, and create also the cutoff. The cutoff is not creating by the shield or something. There is really computed the optical surface so that it's image by image laying on this cutoff line.
And you said like 25 meters. So that means that the hole there in the wall is an extra 15.
Yeah, the wall is in a 10-meter distance, and there is a tube with a shield which is 15 meters long. The latest trends we can see on the cars. During the driving, we can have illuminated the grille of the car with the logo, which is it's really new because of legislation.
Yeah, it was kind of prohibited.
Yeah,
right?
It was kind of prohibited.
Recently.
It's about 6 months old new regulation which allows this logo also in Europe in the cars. And here, this headlamp has a specialty. We can change these signatures. There are, as I remember, 39 LEDs, which can create different shape of the front position lamp or daytime running lamp.
And how do you guys are testing the headlamps, for example, when you want to see how they're gonna look on the road? Are you driving with them on the roof, or you have your own testing vehicle?
Yeah. We have also our own testing vehicle when we have some prototype which is not possible to mount in the serial car because car is not existing yet. We can use our testing car where some fixture is mounted in front of, and we can place there any prototype.
Can we maybe see the matrix lights on the wall?
Yes, of course. Here we can see two modules which are creating low beam and high beam.
I can see even some bright blue element. Is that just a design thing?
This design thing. We can have some blue element inside, but the whole light distribution should be white. The upper module is creating low beam with the cutoff line, which is usual as we saw already on this truck headlamp. But the second module is creating part of the low beam and also high beam. Can we switch on the high beam, please? Okay, there's a full high beam. That's nothing special, I would say. But with this headlamp, we can create a so-called adaptive driving beam, which is special function. With the camera, we are seeing what is in front of car, some driving, opposite driving, and so on, and we can switch off some segments that we are not glaring this opposite traffic.
How fast that process is from the recognition of the camera to switch?
It's in tenths of seconds.
Okay, that's pretty fast.
It's really fast.
Yeah. Okay, and do you think that this latest technology will soon be available even on headlamps for trucks, or?
Sure. Yeah. I'm sure. Depending on the testing you spoke before, because of some vibration tests and so on. That's a really hard thing to fulfill. But from the lighting point of view, I'm sure that it will come.
So these are more fragile when it comes to shake tests because of the technology inside, or?
Yes.
Yeah.
Yes.
Okay. So we've been invited into another room, and where you guys are doing a lot of testing. Yep. So can you tell us what makes this room different from the previous one we've seen?
It's very similar. We can also see some goniometer which can move with the headlamp. But what is special is camera, which is looking on the measurement screen, and we can take a picture from whole light distribution. It's not necessary to measure point per point like on the goniometer, but with the camera we can take one picture, and we have all information about the color, intensity, homogeneity, and so
how it
on.
spreads as well.
That's also a reason why we have here such screens to screen all disturbing light from the reflections from the walls and so on.
Cool.
Now we can see low beam from the truck module we are using for the US market.
Okay.
But we can also look inside the special modules, this ADB. We have 2 rows of LEDs there. There we have some primary optic, which is collimating the light and shaping the light. Then we have some lens which is projecting light. Then it's some bezel or something, it's lens holder. There is some primary optic which is collimating light from each LED. This we call HD 84 because of 84 LEDs which are placing in the 3 rows.
Is that the maximum number nowadays, or?
It's not a maximum number. We can have even more. I have here, which is 1 LED, but split it on the 30,000 pixels, and each independent pixel we can switch on and off.
30,000.
Yeah.
Can't even see it. It looks like one to me.
Yeah, the size of 1 pixel is about a 10th of a millimeter.
And each one of those tiny, almost microscopic, can be like individually turned on and off.
Yes. Not only turn on and off, but also dimming from 0 to 100% of light.
Oh my god.
Firstly, we can look at this HD 84.
Oh, so
Can we
that's the
switch
one
off?
with 84 LEDs that we've seen? Okay.
Yeah.
That looks like kind of usual.
Yeah, it's a kind of usual low beam, but it's creating by the 3 rows, one above another. It can create also the full high beam.
Okay.
And this high beam can be split on the
tunnels.
individual pixel, which is creating by one single point, single LED. It's possible also make some lettering from this module to show what is possible.
If you have 84 LEDs, then you can create shapes like this hello message kind of. Yeah.
It's not possible to drive with such image, but
Yeah.
we can switch on the module.
You can probably go even deeper with the projection, right?
The resolution is absolutely different. We are speaking about 1/100th of degree. It's 100 more precise than this 84. And we can, of course, create some low beam, high beam, and we can also project some symbols on the road in front of car.
So we moved into another laboratory, into another test room. As you can see, I got a new swag as well. And here with me is another great person from FORVIA HELLA. Sir, can you introduce yourself and tell us what is this room for?
Hello, my name is Tomáš Hlaváček. I'm leading System Test Engineering group here. And let's say our group is caring about the preparation of testing. This means we are writing the specifications. We are caring that we will have some fixtures where we will fix the headlamps.
Okay.
And so on, cables, and then we will be able to switch on, let's say, the headlamps and so on and so on. So whole preparation before the testing phase of our products.
Okay. So what is this machine?
Yeah.
What is it doing, or what is it for?
Currently, we are in a laboratory where we are measure the dimension of the product, and we have, let's say, several methods how we can do it. The first one is this, which is, let's say, contact method. So you can see that there are touch probes, and we are defining, let's say, the position where it should be, and then we start, let's say, the program and checking if dimensions are exactly like it should be, because it's, let's say, plastic material and it's not so easy to have it in correct way. We are able to measure microns.
Oh really? Okay.
But let's say according to the drawings, so we are more interested, let's say, in the hundreds of millimeter. Then we have additional method how to measure the dimensions. Contactless method, let's say, is here when we have these optical scans. It's not, let's say, for complete product. That's more, let's say, for the parts, from the
I
headlamp.
see.
So you can see here we are scanning the surface, and then we can bring it, let's say, to PC and measure directly what we are interested in. The last test method is CT.
X-ray. Okay.
Exactly, like in a hospital.
Really? That's like the same CT?
Yes, that's the
Same technology.
Important is that we can see what is inside our product. So when we are interested in how the cables are, let's say, routed inside the headlamp, or when we know that there is something broken after the vibration test, we can check before the testing.
So the CT can see the small crackles.
Exactly.
Whoa.
Yeah, it's expensive, let's say, technology, but it helps us a lot. And you can with mouse just go, let's say, through the lamp and see the points which are interested. We are in the laboratory where we are measure electromagnetic compatibility, and for that purpose we are using this room with, let's say, this pyramid which absorbs the electromagnetic waves, so we have, let's say, stable environment, let's say, for the testing.
Electromagnetic compatibility, what does it mean? What is it for? What are you testing?
Yeah, so we can go inside,
Okay.
and I think that it will be better for the explanation. You can see the product and antennas. So we have, let's say, defined the distances where we should put, let's say, the antennas. And the purpose of the testing is that our product shouldn't have any influence, let's say, of other electronics in the surrounding.
Okay.
So that means we cannot have any influence of front cameras or radars, because then that could be, let's say, a wrong distance measurement, and it could cause any accident. You have also a lot of electronics inside the car.
your car, yeah.
And you have a mobile phone and everything.
True.
Then everything, let's say, what is electronic can have influence on the other electronic. So it's also in opposite way, that when you are calling or when you are using the radars or anything, you can have influence, let's say, on the headlamp. The frequencies are, let's say, from the kilohertz to the gigahertz. So we need to have, let's say, complete band, Bluetooth and so on.
So this is probably one of the most cool testing rooms I've seen so far here. You guys have. Can you tell us what you guys are using this machine behind us for? I can see there is already the same headlamps for a certain truck we've seen multiple times during today already attached in. What is this machine for?
Yeah, that's the favorite lab where we are testing, let's say, mechanical robustness of our products. Currently, let's say, this truck. Especially for the track, it's really high load. It's, let's say, 3 times higher than for the past cars. And also the duration of test is, let's say, 3 times higher. It's like around about 150 hours in comparison with 50 hours, let's say, with the past cars.
So you put the headlamps there and then you start the shaking, the vibration test, and you keep it there for 150 hours. 150 hours.
That's, let's say, the vibration shaker, where it's, let's say, simple coil, let's say, in the magnetic field, who is shaking with the product. You can see, let's say, the expander, then there are, let's say, the accelerometers who are doing, let's say, the feedback, let's say, how we control the vibration profile. The profiles are taken from the standard, or it's, let's say, measured on the car. The cars are driving, let's say, on special road. There are all surfaces, what could be, let's say, during the lifetime. And then it's multiplied, let's say, so we will do more than 15 years life cycle. In trucks, it's like 40 or 50,000 hours. What we see is random test, so all frequencies are included, which is, let's say, from the road.
And they're randomized. Like.
Yes, it's a random profile. Then we have sinus sweep, so we are trying to find out the resonance frequency. It's, let's say, very important with comparison with the simulation. And then we are also checking the cutoff line measurement, let's say, on the wall. The first one is mechanical shocks, where the shock could be like 6 milliseconds or 10 milliseconds. So there are really short shocks which could be during the transport or let's say big holes on the road or anything like that. So it must also be robust enough to survive this. And all this is, let's say, in this climatic chamber.
Oh, okay. So you can even create like heat or cold in it?
Exactly.
Oh, okay.
It could be like from -40 until 120 degrees.
120, and
Yes.
the headlamp still must survive, right?
Exactly.
And all the parts
There are
in it.
cycles. There is not, let's say, just the constant temperature, but there are cycles
Up and down, up and down.
Up and down, up and down, and it must survive, let's say, this test.
So we just left the shock machine, or how to say it, and here we are in a, let's say, more like water testing room. As you can see, as I guess, this machine simulates the rain being applied on the headlamps on when it's riding.
Exactly, we are testing the protection of the water based on, let's say, the specification what we are writing with the customer.
Are you using only water or also chemicals sometimes? Or?
No, there is just a water, but we can set, let's say, the temperature of the water and the pressure.
Okay.
And if it's, let's say, really high requirement, so we are using high steam jet to do that from all sides, let's say.
And how long is the headlamp there getting shower?
It depends, but it's like from 4 hours to,
oh my God,
to 16 hours.
Okay, so our probably last stop here at Mohelnice is at this floor where these guys here have a lot of machines to do a lot of cool tests. So we will just like run through it. So can you tell us what all you have at this floor, starting with this monster?
Yeah, we have seen, let's say, the climatic chamber on the vibration shaker, and there are, let's say, the special application how to test, let's say, special environment what is, let's say, outside. So when you are outside in the car, so you know that there is not, let's say, just the temperature changing, but there are also solar radiation, or sun radiation, where we can
so you can
do
simulate
that here.
sun.
So exactly, it's composed from 2 climatic chamber. You can see here that, let's say, it's the first one, where we have inner space from the car. So it's usually heat from the engine.
From the engine, yeah, okay.
Then we have, let's say, this side, what is, let's say, outside climatic conditions. So then there is the sun, what I have mentioned.
And those pipes are like blowing air or water?
Water.
Oh, so you can do like the heat from the engine, sun, air, and water all at the same time.
Exactly. And that's, let's say, the most of time it's for development for the fogging and defogging of the headlamp. That means the headlamp has some parameters where when it's fogged, so we have time how fast the defogging reaction must be.
Makes sense. And anything else? I've seen a big black dark room at the back of this floor.
That's, let's say, another type how to test whole lamp lifetime, like vibrations. It's, let's say, inside the climatic chamber. On the opposite side, it's a 10-meter distance wall where we are projecting, let's say, the light. And we are checking how the light output is shifting up and down.
Because of the climate and temperature changes that has been applied on it.
Exactly. Temperature changes. There is also the humidity, like from 30% until 95%. And the lamp is moving and also the lighting all functions. So there are some cycles programming and like in whole time. And how long is the headlamp being there exposed to this test in the back dark room? It could be like 40 days until 3 months. It depends. What are the expectations of the customer and so on.
Oh my God, that's amazing. Well, guys, we cannot thank you enough for showing us everything, you guys. And we didn't see everything. Trust us, there's plenty more. But it was so exciting to see and learn how complex and difficult the process of creating a headlamp is. And thank you so much for giving us this tour and showing us around.
You are welcome. Unfortunately, we have, let's say, more equipment for the testing, but
maybe if our fans will like this episode, let us know in the comment section, and maybe we can come for a second visit and do another episode, because there is still a lot to show. And so this part here at Mohelnice was dedicated to the design and then the development and the testing. And so after that, when all the tests are being passed and the headlamp is shipped to production, right?
Exactly.
Okay. And some of them are being produced at Slovakia in Kočovce, right? To where we can do the magic teleport right now, and then we will continue from there. And so we magically teleported ourselves to Slovakia, and here we are in FORVIA HELLA plant, one of the biggest, probably the biggest even in Slovakia, in Košovce. And here with me is this amazing gentleman. Sir, can you introduce yourself and tell us what you guys are doing here?
Hi everybody. You're completely correct. FORVIA HELLA Košovce is the biggest plant of FORVIA Corporation in Slovakia. My name is Matej, I'm the plant manager in Košovce. I do welcome you.
Thank you. So what you guys are doing here, I guess it's about lights, right?
It's about lights. Everything is about lighting and shining in Košovce. We are producing main lights for personal cars, vans, and also truck business.
Can you somehow hint us which truck businesses? Is it German OEMs or maybe Swedish?
The best ones, the Swedish truck business.
Okay.
For trucks, it's Swedish customers. For personal vehicles, mainly German. German customers, some electrical vehicles, and what we are proud of, we are also producing vans for worldwide German customers.
Perfect. And you mentioned that this plant, this FORVIA HELLA plant in Košovce, is the biggest one in Slovakia. So there are more of them, I guess.
Yeah, that is. In terms of FORVIA HELLA group, there is 3 plants in Slovakia. It's Košovce, which are dedicated for main lights. Then we have a colleagues in Trenčín, which is internet lighting, and Bánovce, which is rear combination light. Plus in FORVIA group, we have another plants in Lozorno for seating, in Hlohovec for interiors, and Košice interiors, and some small plants for clean mobility, so it's exhaust systems.
Can you give us some numbers, because you said you are the biggest plant? Can you give us some numbers, like how many, I don't know, lights you guys are producing every year, or how many not customers, so employees you have here? And
Okay, so a bit of secret data. We are around over 300 million euro annual sales plant with around 1,600 plus employees. For Volks, we produce over 2.5 million lights a year.
2.5 million lights.
Lights, yeah. Plus some models which we are shipping also worldwide, like we are shipping modules to Mexico, for example.
Mexico, even.
Yeah, we do also this kind of business. Our products you can find in Europe and also worldwide.
Okay, and could you like maybe shortly describe us how the life of a light, like how a light becomes to life here, and like what's at first and how the production goes through it? And
so at the beginning is a small ball which we call granulate. It's a plastic substance which we are using for molding machines, where we are molding different plastic parts of the light. So either it's housing, or it's a part of reflectors, or it's the cover glass. Later on, depends on a product, we do either lacquering, or we are doing metallization, or we do onion assembly. Also, what we are doing here is lenses, which is a difficult process, but we're pretty proud of it.
Okay, and I heard that you arranged one of your colleagues to take us through the production plant today to basically show us and our fans.
Sure.
How it looks like, how you guys are working on lights here.
Yeah, sure. So you're welcome here. Our colleagues will guide you through the production, and you will see how a light it's becoming a light from a small granulate to the shiny, all the way to a really luxury light with a lot of functionalities.
Thank you so much, sir, for all the information at the beginning, and I believe now it is our pleasure, and thank you for that again, to be taken for a commented, guided tour through the plant here.
Yeah, welcome again, and enjoy the tour.
Thank you. So here we are at one of the part of the FORVIA HELLA production plant in Košovce, Slovakia, and this is a assembly plant for FORVIA HELLA lights, and here with me is another gentleman from FORVIA HELLA. Sir, can you introduce yourself?
Yeah, of course. Hello, my name is Jan Ondrejkovic, and we are now in the assembly production. I'm an assembly engineer, and here is one production line which product headlamps for vans.
So can you describe like what each of the station does?
Yeah, for sure, we can go check it.
Okay, let's go check it. Benny, don't get hurt. There is a lot of traffic. Safety first, remember, right?
This is the first station when they assembly some LVR to move the modules. So this one and some drive elements on the back of the headlamp. This is just harnessing, so they have to put harness there and they have to move him in correct way. Yeah, this is automatic screwdriver which screw the HLA and drill. So this is just the station for this. So here they assembly some fan and MLS group. That's for 3 function. On the next station, they assembling the module in the headlamp. Like you can see, they connect the connectors to the module and they put the module to the housing.
And they are each station also do some tests, right? That if their step is correctly done.
Yeah, exactly. But in this station, she just put it there and she move it to the next station. And in this station, it will do like push-pull test for make sure that it's correctly in the housing. Now we can see the push-pull test. This part of working station, do the push-pull test.
So what is the machine testing like? If there is some wheel to move,
yeah, exactly.
Inside the light.
If it's correctly like pulled to the housing and it's supposed to
no moving.
No moving, exactly. Yeah. So in the car, the vibrations and this stuff.
Yeah, makes sense. Okay.
So she put there the headlamp, the group, which is already complete, and she add there this button bezel.
Oh, okay.
And 3 function group, this light guide and some cover. And now
and the machine will screw it all together.
Yeah, exactly.
And why your colleagues are like blowing the air so many times, like to remove the dust?
Yeah, exactly. Yeah. So
it must be perfectly clean.
Exactly. Right? So they need to clean it with the air.
And this is fully out. This is fully
automatic.
robot.
Yeah, exactly. It will take it from the vacuum cleaner, then put it to the black box, which is a light test, and then it needs to put together the housing and the lens. So it plasmas the housing, and after
that's a plasma.
Yeah. Oh. So and after the plasma, it glued all the way around the housing. Yeah. The robot will take the lens and put it on the housing. Plasma. In this station, it tests for the leakage.
So they are testing like if the cover really fits to the housing.
Exactly.
There's no space, no gas, no gap. Okay.
Yeah, exactly. Yeah. After this test, they put it to the laser, and in this laser, it just scans the label and it knows what type of product it is. And this is the final station. In this station, they like check visually if everything is okay. If there is
so that's like a final checking station.
Yeah, okay. Exactly. Final checking and put it to the system, and they just check the decorative, the lens and everything.
I'm really impressed like how many checks you guys are doing. Like every station checks their own work. Then you have few stations that are only for checks, and then one final check as well.
Yeah, everything has to be okay.
Everything must be perfect, right?
Exactly. And then they put it to the package.
And that's ready for?
That's ready for shipping. Yeah.
Okay.
So now we are in the assembly where we made the cover lenses.
Okay.
Yeah, we made it from clear granules, and we.
So those are like tiny plastic parts
Yeah,
that you guys are
exactly.
melting,
Exactly.
drying first, I guess.
Yeah,
and-
we,
no?
yeah, we put it to the press machine,
Uh-huh.
and the press machine will dry it and press to the part we need.
So you have like form for each light. You
Yeah.
have a special form,
Yeah, exactly.
and these machines are taking the granules and they are injecting it into the form and then.
Exactly.
Okay.
Yeah, as you say, exactly.
Okay. So maybe we can walk around and see a few interesting things about this place.
Yeah, for sure.
Okay. You can see that that's the form, right?
Yeah, exactly. This is the form.
The silver part. That's where the plastic material is being injected.
Exactly.
Oh, I can see some trolleys up above. So that's how you guys are moving the lenses, the
Yeah,
covers
exactly.
through the whole.
After the pressing line press the lenses, the robot will automatically take the lens and put it to this mount track, so it will automatically move the lenses there
From station to station.
From station to
basically.
station,
Okay.
exactly.
Those lenses that are being moved are constantly under air
Under
pressure.
Air pressure, yeah,
Okay,
exactly.
that's how you make it clean. Okay, how you keep it clean. All right. So we moved into another part of the plant, and we can see that those lenses that were poured are coming here. They're cleaned. They are painted multiple times, cleaned by multiple steps as well to be completely cleaned, and they are painted to be able to survive longer. Then they are heated, and then they are checked by your colleagues, also by eye.
Yeah, exactly.
Perfect, perfect. Thank you again for your time, that you took us also very briefly into this part.
You are welcome. Thank you very much and have a nice day.
Thank you, thank you. That was our 2-day trip to FORVIA HELLA. It was super interesting to learn more about how something we see every day on the roads, either on passenger cars or on trucks. So something like headlamps, for example, is being made, how complex that process is. Massive shout out to our friends and contacts from FORVIA HELLA to inviting us to allow us to do this episode for you guys. We hope you're gonna enjoy it, and as always, we're gonna see you at the next episode.